Assalamualaikum warahmatullahi wabarakatuh. Hi, we are from Aina Najwa Arisha's Mentor Menti group. We would like to explain the answers for the paper set 2.
Question 1. Diagram shows the apparatus set up for the electrolysis of concentrated and dilute sodium chloride by using carbon electrodes. At which electrode, a bubble of colorless gas will form. So the answer is electrode 2. It is because dilute sodium chloride contain high amount of H plus and OH minus ion compared to concentrated sodium chloride. Sodium chloride contain H plus, OH minus, Cl minus and Na plus ion. Cl minus ion will attracted to electrode 1, which act as anode and form yellow color of gas. H plus ion will attracted to electrode 2, which is act as cathode and produce colorless bubble of gas. Question 2. Which of the following statement is true based on the diagram? The answer is B, because the electrons flow from reducing agent to oxidizing agent. X act as oxidizing agent and Y act as reducing agent. Iron 2 sulfur undergoes oxidation because iron 2 ion oxidized to iron 3 ion.
We're moving to question number 3. Diagram 9 shows the apparatus set up to study the transfer of electron at a distance by using the U-tube. As we can see, there's 2 carbon electrodes, one with potassium iodide solution and one with acidified potassium manganate solution. And at the bottom of the U-tube, we have dilute sulfuric acid. So the first question is, the half equation below shows the reaction occur at Y. Complete the half equation. So they give us an incomplete half equation and we have to complete them. As we all know, in order to balance the equation, we have to make sure that the left side and the right side is in the same value. Why we put 4 in front of the H2O? Because when we times H2 times with 4, we have 8H. So it equals to the left side 8H. O times 4, we have O4, and it equals to the left side of the equation, O4. And why we put 2 in front of the E? Because at the left side we have Mn. When we plus with 2E, it became Mn2 minus at the right side of the equation. Moving to the 2 Roman question. Based on your answer in 3C1 Roman, draw the arrows on diagram 9 to show the direction of electron flow. So that's how we draw arrows to show the direction of electron flow. It flows from X to Y. This is because electron moves from reducing agent to oxidizing agent, which means X is the reducing agent and Y is the oxidizing agent. Moving on to question number 4, diagram 10.2 shows the result when iron nail is coiled with copper wire. Iron rusts faster when coiled with copper wire. Suggest other metal that can replace copper so that rusting can be prevented, and explain why the metal is chosen. Include in your answer expected observation to prove the rusting does not take place. So, other metal that can replace copper is magnesium. Why? This is because magnesium is more reactive than iron. This prevents iron from losing its electrons and becoming oxidized. Experiment to prove the rusting does not take place when we wrap 2 nails with 2 different metals, one with copper and one with magnesium. Connecting a more reactive metal from higher in the series protects from rusting. And as we can see in the experiment, the nail wrapped with copper will rust and the nail wrapped in magnesium will not rust. To conclude, a lower, which is less reactive metal, accepts electrons from iron and speed up the rusting process.
Question 5. Ethanol is an example of an environmentally friendly fuel because of its ability to burn completely. The question asks to draw the energy level diagram for the combustion of ethanol. So we can see the combustion of ethanol is an exothermic reaction. So the energy content of product is lower than the energy content of reactant. Next, question asks to predict whether the temperature of the surrounding is lower or raised. The answer is the surrounding temperature raised because the combustion of ethanol is exothermic reaction. So, when combustion occurs, carbon and hydrogen burns and release more heat energy that will raise temperature of surrounding. Question 6. Question shows the table of the results about heat precipitation for magnesium carbonate. 1. Calculate the heat of precipitation. First, we need to calculate the average of initial temperature, since the experiment used two different solutions and have two initial temperature. Then calculate the temperature change by subtract the initial temperature with the final temperature. This change of temperature shows the fall of temperature, which means the reaction is an endothermic reaction. Then calculate the heat energy by using formula MC theta. Calculate the number of mole of magnesium nitrate using the volume and molar volume given. Use the formula number of mole equal to mv divided by 1000. Through the chemical equation, compare the number of mole of magnesium nitrate and number of mole magnesium carbonate. Then calculate the number of mole of magnesium carbonate. Then calculate the heat of precipitation by multiply the heat of energy with 1 over 0.05 mole. Question asks to predict the value of heat precipitation if sodium carbonate replaces the potassium carbonate. The answer is the heat of precipitation remains the same because the volume and molar volume used by sodium carbonate is same as volume and molar volume potassium carbonate used. So the number of mole of these two solutions must be same as well as the heat of precipitation.
Question 7. Table 4 shows the heat of neutralization for two sets of experiment using different monoprotic acids, V and W, reacting with potassium hydroxide solution. So we have two sets with different heat of neutralization. 1 Roman, based on table 4, name one example of acid V and acid W. W is hydrochloric acid and acid V is nitric acid. This is why, because nitric acid has higher heat of neutralization than hydrochloric acid. 2 Roman, explain why there is a difference in the values of the heat of neutralization. First, it is affected by strain of acid. Hydrochloric acid is stronger than nitric acid. Hydrochloric acid number in pH value is lower than nitric acid. And to conclude, the lower the number of pH value, the more acidic the acid. So that is why hydrochloric acid is stronger than nitric acid. 7D. Calculate the change in temperature of the mixture in set 1. Specific heat capacity of solution given is 4.2 joule. First of all, we have to calculate the heat energy released by using formula MC theta. M is the mass of the solution and C is the specific heat capacity of solution and theta is the change in temperature. We add the mass of the solution, which is 50 plus 50, and we times with the specific heat capacity solution 4.2 and we times theta. So it becomes 420 theta. But 420 theta is in unit kilojoule, so we have to convert them to joule only. So it becomes 0.42 joules. Then we have to calculate the number of moles of nitric acid used and the number of moles of potassium hydroxide used. And both give us the same answer, which is 0.1. So here we can calculate the change in temperature. 0.42 theta times 1 over 0.1 equals to 57. Why 57? The value from the table 4 shows the heat of neutralization is 57. So we put 57. And we got the data 13.6. To conclude, the change in temperature of the mixture in set 1 is 13.6. 7C. By using either acid V or acid W, describe an experiment to determine the heat of neutralization. In your description include procedure of the experiment, the thermochemical equation involved, and energy level diagram for the reaction. We start with the procedure. First, 50 cm³ of 2.0 mol dm³ sodium hydroxide is measured using a 100 ml measuring cylinder and poured into a plastic cup. Then, the initial temperature of the sodium hydroxide is determined using a thermometer. The measuring cylinder is washed with water and then rinsed with the hydrochloric acid solution. 50 cm³ of 2.0 mol dm³ hydrochloric acid is measured using a 100 ml measuring cylinder. Its initial temperature is recorded using a thermometer. The hydrochloric solution is then poured into the sodium hydroxide solution. The mixture is stirred and the maximum temperature at 10 is recorded. The equation is NaOH plus HCl equal to NaCl plus H2O. The energy level diagram shows that this reaction is an exothermic reaction.
Question 8. Monomer polymer Y is propane. Question asks the structural formula of polymer Y. Polymer Y is polypropane and structural formula is as shown. And outside the bracket refers to the number of monomer chain. Next, explain how properties of polymer Y make it very useful but at the same time cause environmental pollution. Polymer Y is light, strong and hard and used as plastic bag. However, these polymers are durable and take a very long time to disintegrate. This will cause serious pollution and affect the food chain of creatures.
Question 9. What is the name of above reaction? The answer is saponification, because saponification is the only process show how soap can be prepared. Next, the soap produced is potassium palmitate. What alkali should be used? Prepared soap. Only two alkali produced, which is sodium hydroxide and potassium hydroxide. In order to produce potassium palmitate, we need to use potassium hydroxide. Next, what is the homolog series of palm oil? Palm oil is an ester because there is fat and oil contained in palm oil. Next, for the anion part of the soap must draw double bond O and the single bond. Question 10. Based on the statement, explain the effectiveness of cosmetic materials that use nanotechnology. In cosmetic industry, nanotechnology allow enhanced properties in many areas including UV protection, deeper skin, deliver nutrients to more layers of skin cells. Nanotechnology also allows the packaging of many ingredients in semi-soluble packets that break down as the product being applied.